Hey guys, welcome to Balancing Chemical Equations, practice sheet number 2, problem number 5. So we went from problem number 4, if you remember, was a skeleton equation. This one is a word equation. So we have to write out the skeleton equation, then we have to go ahead and balance it. So one of the things we always remember diatomic elements if we have any. So the word equation is hydrogen plus oxygen produces water. Pretty simple. So we're just going to go ahead and start off by taking our hydrogen plus oxygen yields water, which is H2O. Now, I like to look at this and say, okay, what are we going to do from this point? And I'm not going to do that. I'm just going to tab over a little bit. So there we go. We look at it. Hydrogen plus oxygen yields water. Well, what did it say right here? Remember diatomic elements. So which elements are diatomic elements? Well, let's look at the periodic table. And I've always said that on the periodic table, we have a nitrogen, oxygen, fluorine, chlorine, bromine, and iodine, plus one more because that's only 6 elements. And we have 7, and they make us 7 on the periodic table, plus hydrogen. So we go back to the problem, and we say, hydrogen, is that diatomic? Yes, it is. So we have to go ahead and put a 2 there for diatomic. Is oxygen diatomic? Again, if I go back to the periodic table, it is one of my 7. So we'll go back here, and we're going to put a subscript of 2 right there. There we go. If I learn how to do this. So from this point on, we're just going to go ahead, and there is our unbalanced chemical equation. So now we got to go ahead and balance it. So what are we going to do? We're going to go ahead and type in our elements that we have. So we have hydrogen, and we have oxygen. So I have hydrogen, oxygen on this side, hydrogen and oxygen on this side. So how many of each one do I have? Well, I have 2 right here of hydrogen, and oxygen I also have 2. But on this side, I have 2 of hydrogen, but I only have 1 of oxygen. So what element do we have to start off with? We have to start off with oxygen. So let's go up here, and we have to make this. Now again, I cannot change the subscript. I can't put a 2 right here. If I put a 2 right there, I would have H2O2, which would be hydrogen peroxide, which is not water. It looks like water, but it's not water. So we have to change the coefficients which are in front. So if I put a 2 right there, that means now I have 2 oxygens on this side. So I can put a 2 right there. But it also changes the number of hydrogens. So I go from 2 to 4. So now I have to go back over to the other side. And I can't put a 4 here because it's diatomic, not tetratomic. So I'm going to go ahead and put a 2 right there. So now I have 4 hydrogens on this side. And so I put a 4 right there. So I have 4 hydrogens on this side, 4 on this side, 2 oxygens on this side, 2 oxygens on this side. I am balanced. So now we have a balanced chemical equation. So our molar ratio is 2 to 1 to 2. And again, we can put a 1 right there. Where it's not necessary to have a 1. Sometimes it's easier for you to understand that there is a 1 there. There can't be a 0. Because if there was a 0, it'd say I have 0 oxygen and I need at least 1 diatomic molecule of oxygen or 1 molecule of oxygen. So we go ahead and look at our numbers that we have right here for our molar ratio, and we ask, can we reduce? Since I have a 1 in it, there's no way that we can reduce. So we're going to go ahead and make bold and highlight, and that would be our answer. So for question number 5, we wrote out the skeleton equation, we balanced the skeleton equation, we checked to see if the molar ratio could be reduced. It couldn't, so there's our answer. 2 to 1 to 2 is our ratio, or a molar ratio, for this problem.